Jupiter may be the largest planet in the solar system, but its days are numbered when we deploy the most powerful bombs on Earth to destroy the gas giant. How many nukes would be required to complete the task? What obstacles would these rocket-bound bombs encounter on the way? And would a single nuclear detonation set the world on fire? And this is what would occur if we destroyed Jupiter. Even low-yield nuclear weapons, such as those dropped on Japan by the United States during World War II, had the explosive power of 15 to 20 kilotons of dynamite each. This is a witness to how potent nuclear weapons are. Because they utilize the powerful energy release capabilities of nuclear fusion or fission, they are extremely flammable. The same processes take place in our own sun as well. So be careful when transporting these items to Jupiter. A fireball as hot as the sun's core may obliterate you with one careless move. One single bomb wouldn't necessarily be enough to blow Jupiter into pieces. It's a good thing in this scenario that there are many nuclear weapons on Earth. Getting them all off our planet might be the safest course of action. The actual amount is difficult to determine because to the top-secret nature of military operations, but estimates place the worldwide arsenal at roughly 12,700, with the United States and Russia competing for first place with 5,500–6,000 warheads each. Okay, putting it off won't help. Let's launch these missiles as soon as we can. Between Earth and Jupiter, there is a range in distance of from 590 million to 970 million kilometers. The journey to the gas giant used to take missions like the Galileo space probe around 5 years. But it wouldn't take this long with our missiles. Galileo had to be slow enough to enter Jupiter's orbit. You'd only need to allow 550 to 650 days to complete the mission if we simply strike the planet head-on. But you shouldn't be too aggressive and quick. You don't want to accidentally destroy something else. It would be simple enough to avoid the Moon and Mars, but navigating the asteroid belt successfully would be like navigating a minefield. Between Mars and Jupiter, there are millions of asteroids, and even while their average separation is a safe 966,000 kilometers, it can occasionally feel a little crowded. And Jupiter is partly to blame for this. The planet's massive gravitational influence causes many of these to group into clusters known as families, carelessly navigate through one like the Flora family. Furthermore, you'd best hope none of our rockets strike any of the 400 asteroids in its area. You should attempt to launch your rockets through the Kirkwood Gap for the best chance of success. You wouldn't want to watch all of our planet's nuclear weapons detonate at once and generate a blinding chain of explosions, so these parts of the belt are nearly free of asteroids. Reaction is the first of our bombs detonated on Jupiter, before we reached our target. Similar to what happened when the Shoemaker-Levy 9 comet slammed into Jupiter in 1994, you would see dazzling flashes back here on Earth. But that only released 5% as much energy as the Tsar Bomb A, the largest bomb ever created. Jupiter's days wouldn't have to be numbered with thousands of our nuclear weapons, right? Actually, not quite. Even though our nuclear weapons are capable of producing an explosion that is hotter than the Sun, Jupiter's hydrogen wouldn't completely ignite as a result. Simply said, it lacks the density to support nuclear fusion. Jupiter wouldn't entirely explode either, even if every bomb were to go off. We would have to discharge as much energy at once as the Sun does over the course of 160 years in order to do that. And for that highly energetic result, about 1 billion nukes would be required, somewhat more than the 12,700 in our arsenal. That many bombs would require a total mass of materials roughly twice as huge as Jupiter's Ganymede, the largest moon in the solar system. Being larger than both Pluto and Mercury, it is no small accomplishment. Okay, that was definitely disappointing. Maybe you'd be better off seeing what could happen by taking things to the extreme here on Earth. Like dropping a nuclear bomb in the ocean's deepest section. However, but that's a story or another, and that's all for today, guys. Don't forget to hit like, subscribe to our channel and ring the bell icon for more amazing videos. And thank you for watching.